Welcome everybody to another Sensofar applications webinar. Today we will talk about tribology and corrosion, and we will explain how to measure and how to analyze this kind of samples with our 3D optical profilometer that we're doing here in Sensofar. So here you have a bit of sum up about the topics that we will talk today. First, we want to introduce a bit the company. Here we are. This is the team of Sensofar, a company that was founded in Terrassa, a city that is really near to Barcelona. And it was a company that it was founded in 2001 as a spin-off of the university UPC. So what we do? What we do is characterization of different surfaces in the micro and nano scale. So our goal is to our application plan is to have maybe some quality inspection and try to provide this quality inspection to R&D. So as we have told before, this company was created in Terrassa, but we have also different offices in Asia, in Shanghai, for example, and Taipei, in Germany, in Munich, and in the US. Also, you can see a lot of points around this matter. These are worldwide presence to our distribution network. And well, let's present the product that we think that matches best, or the ideal product that we have to measure the tribological samples, which is SNEOS. We have 20 years of experience with this product, so this is the 5th generation. And what it makes it different is that it has 4 different technologies in the same sensor head, and also a motorized stage that is perfect for doing extended measurements. So here we present the 4 technologies that we have talked about them in previous webinars. We have the active illumination focus variation, confocal, interferometry, and spectroscopic reflectometry. But we will emphasize these 3 ones, because we think that they're the ones that are relevant to measure the tribological samples. Just to sum up a bit, the active illumination focus variation is more done to measure some shapes. We have then the confocal to measure more roughness, or also samples that can have a bit of thickness or nanoscale features. And finally, we have for smooth samples, we have the interferometry that also has the capability to measure thickness. It will depend on when you measure thickness, on the material and reflectivities of the different layers. So I assume that there are a lot of tribological experts attending this webinar, but we wanted also to make a bit of introduction about what tribology is, because maybe there is someone that can be interested. Tribology is the study of interaction of sliding surfaces, and it's the study of the coefficient of friction that were appearing after some tribological test, or how you can give lubrication properties to your surfaces, maybe applying some coatings or maybe applying some laser texturing. Also, we have some examples about corrosion. That it's what makes it different is that the interaction is done by chemical and electrochemical components over your surface. So the markets that this kind of application is facing is advanced manufacturing, of course, aerospace and automotive. We will see an example of medical devices, paleontology, and of course, it's very important in the tooling industry to analyze maybe the wear or the roughness of our tools. So here we show you some examples. On the left, we have an example of wear applied over a metallic surface. In the middle, we have a tool with corrosion. And on the right side, we have an image in the micro scale where we can appreciate the laser texture that has been applied over the material to give the lubrication properties. So now we will explain why Sensofar and how to measure the samples with our system. When you do your tribological test, finally what you want to measure is the coefficient of friction, maybe the removed material and measuring the wear, or the addition of material to your sample. So with the topographic evaluation, what we can do is to measure the shape of your sample, also the wear appearing, and if you want to go deeper, we can also measure the roughness. So as we have commented before, we have three technologies in the same sensor head. We're able to measure a wide range of different samples. For example, we can see on the top of this slide that we have two samples with a certain shape. On the right side, we have another sample with, I would say, a rough sample. Here, below, what we have is two examples of laser texturing. And finally, what we can see is a surface where it has been applied a tribological test of a tip with a certain load. So let's focus on some specific examples that we have measured here in Sensofar. Here we have a multiple wear test. And what we have done in this case, well, what we are doing is to measure the wear of these 5 groups. And what we wanted is to do it fast and accurate. So what we have decided is to select interferometry, because then what we can do is to maintain the best vertical resolution of 1 nanometer, but with a low magnification objective, so we then are able to cover a large field of view. So getting this topography and exporting to our analysis tool, SensoView, what we can do then is to apply a foam removal to flatten the sample, and then apply a profile to maybe measure the depths and widths of each group. We can export also all the data to our advanced analysis tool, which is SensoMap. And then what you can do is to put all the different profiles of the different groups in the same plot. So then you will be able to compare them. Here we have the same example, but what we wanted to see here was the wear. We wanted to measure the volume of the wear. So what we wanted in this case is the maximum accuracy in the lateral and well, having the best lateral and vertical resolution. So we have used in this case the confocal technology with a magnification of 50x. We have obtained again an extended measurement, and we have exported the topography to our analysis tool SensoView again, but in this case we have applied the operator volume. What we have done then is to put some dots around the groove, and then what it does is to select this area that we can see in green, and it's doing a mean plane between all these points. So all the measured points that are above this area in green are measured as peak, and all the points that are below this area are measured as hole. So if we see this value in hole, is the volume calculated of measured points and that are below this mean plane. So here we have another interesting example. In this case, the wear test has been applied on a cylinder. This is a piece of a nuclear reactor. And as the sample has this cylindrical shape, we have found that it's the better solution is to apply active illumination focus variation, but trying to also get good accuracy and then applying an objective of 50x. So we have exported again the topography to our analysis tool. And in this case, we have done a cylindrical form removal, and this way that has been to put again some points around the tribological test, or the part where we want to measure the volume. And we have said to the software to make the leveling or the form removal, and not in this zone, but the zone that is out of this zone. So finally, we have flattened the topography as we can see here. Later, we have applied again the operator of volume, and with other dots applied, we have been able to do what we have seen before with the groups. So another case, in this case, what we will do is to measure roughness. This is a wafer polishing pad, and we have obtained it as normally we measure roughness with confocal, but in this case, the roughness is it's really rough. We have preferred to use active illumination focus variation. So we have obtained this topography, and if we export it to SensoView, we have the operator of the surface texture parameters, or the ISO 25178, that automatically can apply the filters depending of the field of view that you are inspecting, can apply automatically the filters to analyze your sample, but also gives you the choice to select for example, the F operator, the S filter, or the L filter, depending on your requirements. We can export then also this kind of topographies to our automatic analysis software, which is called SensoPro, and we have this interesting tool that I will show you how it works. In this window, we have put a set of samples, of roughness samples, with similar characteristics. And in the window below, we have put another set of samples that have another roughness characteristics. We have chosen the different filters, and we have also select the parameters that we want to measure. So when you apply analyze, what it does, what the software does, is to get a statistical data about all the roughness areal roughness parameters of the different sets, and it compares them and can give you information about which parameters are relevant for each different set of samples. Because we can see here that these parameters that with the green rating says that in this case, for example, is the SDQ, this parameter will be really different between both sets of samples. But we can see here that, for example, the SAL or the SZ, in this case, won't give any relevant information, will be really similar. So now we have explained a bit the company and the technology and how to measure the samples. And now what we will do is to explain two case studies of two companies that are users from Sensofar, and explain how they have given a solution to their application. First, we start with Oxford Lasers, that what they wanted to do is to apply some dimples or some holes with this kind of laser texturing, and what they wanted to do is to monitorize the process, giving some iteration to obtain a better process to reduce the coefficient of friction. So with the Sensofar system, they have been able to measure the depth, diameter, and also all the material that was redeposited around these dimples. So after doing some iterations, they have arrived to a reduction of 25% of the coefficient of friction that I think that it's quite impressive. We can see here the different profiles that we're obtaining. Here we have the standard method, and we can see a bit of peaks around these dimples. And finally, they have been able to analyze that with their new method, this material is not appearing. Another case is the case of Antogir. In this case, it's a medical implant company that they have to manufacture their implants with a certain roughness. So they wanted to analyze that each sample had a specific roughness, and there was not a tool during the manufacturing process that was not doing good its job. So what they required is to analyze the different roughness parameters, for example, the SA and the Z, but the one that was important to do the non-compliance or compliance test was the SMR. The SMR is a parameter that puts a threshold in your profile and calculates the percentage of material that is above this threshold, and it's represented in this curve. So what happened? That they needed specifically a non-contact profilometer, because if they were using an stylus, it was adding some defects after the analysis. Now, what we will do is to have a fast review about some worldwide publications. Here are the institutions that we will talk about. Starting, for example, with this article about the Brazilian Nanotechnology National Laboratory, that what they did is a nickel-based tool, and they wanted to know how was the effect on the wear and the adhered material after doing some tribological tests over a steel plate when this tool was, when it was applied to this tool a certain velocity of rotation and load. So they finally found, analyzing the profiles and comparing the tool before and after the tribological test, with what's the optimal velocity and load. Here we have another case. In this case, there is an alloy that is cooled from, it's a cylinder of a certain alloy that is cooled from below. And then what they have done in the University of Campinas is to take some slice of the sample, and then they have made the tribological test with the same conditions. And finally, as you can see here in this plot, they have analyzed the different profiles. Changing the percentage of aluminum in the sample, they have obtained different tests and different results. This is another case of the University of Shanghai, Shanghai Jiao Tong University, where they are analyzing how to reduce the coefficient of friction by applying some graphene coatings. A similar case is the case of applying of the University of Toulouse, where in this article they show again how to reduce the coefficient of friction, but in this case applying some nanomaterial coatings, as can be the carbon nanotube or the graphite. This is another case of the Chalmers University of Technology. In this case, what they have analyzed is how was the roughness of a tool after doing some tribological tests. So in this case, they have taken this topography, they have done a foam removal, and they have been able to analyze how rough was the sample after that. And finally, we wanted to show you an example of the National Center of Metallurgical Research in the CENIM and CSIC in Madrid, where they have analyzed again how they can reduce or maintain the coefficient of friction applying some laser texturing over the sample. You can see here some rhomboid forms and how the angle of these rhomboid forms was affecting to this parameter. If you want to have an idea, here we have some other reference customers, for example, the Fraunhofer Institute or the University of Liverpool. And also other examples like Techniker or again the Salim as we have talked before. So now we will do a live demo.
Thank you, Néstor. So as Néstor said, we have a little surprise for you today. Minimize that. Let me open the. This is the Sensoscan software, which is our software, proprietary software to manage the system and to take the decisions, right? So here we have exactly the same sample we used for the presentation, all right? So how we normally operate with this system? So we normally focus. The system has the capability to do auto light and autofocus. Then we select low magnification objective like a 5x. In this case, the field of view is I think it's 3.5 millimeters by 3 millimeters. So what we do is we take normally an overview of the sample. Okay, I'm repeating that, it was already there. But this option is very nice to navigate through the sample. Okay, so we can go to the first test, second, third, all right. So if we want to take a measurement here, I will select, for example, we try to do with interferometry. I will select a 10x 10x lens. I can do auto light. I can focus manually or with autofocus. Click again, auto light. Now, if we want to cover, I can zoom in this part. I can select first part. And now from the software, I can indicate the software to go from here to here. Okay, so automatically the software is telling you that you need to take 2 acquisitions. All right. So I will click acquire. Now the system is doing these 2 scannings. One, the second one, we are doing a 30 microns travel range. Right, and here you have, okay. So you have the topography. We can, for example, we can level the surface. Okay, and if we want to calculate the volume, it is quite easy, in fact. So we can select the volume, and select the leveling option, then we can go through the surface, right? And here you have all the values, which is above and below. Okay, the average plane you have outside. All right, so of course you can take the profile. You can take the profile through the lowest point. Well, in this case, we have a hole here. But if you want to calculate the height from this point to this point, okay, you have this 2.6 microns even. It's quite easy, and you can do an average. All right, this is for tribology test. Then we have it's another sample. It's a very rusty sample. You can have a look at that. But then let's do that. So this is very different. Okay, now the customer. Well, I mean, let's try to measure take a roughness measurement here. So first of all, we try to focus the sample. I will select 20x lens. Normally, when we measure roughness, either we use a 20x or a 50x. These are very common. So focus this. Let me getting closer to the sample. So here you have, you see, is a pretty rough surface. So in this case, interferometry will be very hard to take this measurement. So we can switch to confocal, even we can select the 3D auto mode, and then we click acquire. Okay. So right now the system is automatically calculating the light settings and the travel range. We are taking the topography and the color information here. Okay. When it's finished, our basic and our analysis for our software analysis called Sensofar is opening, and then either we have the 3D map, we have the stack image, and also we have the color information, right? So you can see it's pretty rough. I can increase the scale. Then if you want to calculate roughness, in this software is very easy. Automatically you can go to SA icon, and the software is going to apply automatically the roughness filterings recommended by the ISO 25178. We click apply, and the software is removing the waviness. We keep the texture, and here you have the values of SA, which is in this case 846 nanometer. Right? If you don't want to calculate the area and you are more interested in the profile, we can delete that. We can select a profile around here. We can select RA, and it will be the same. Okay, now it's applying another ISO 4287. Click apply. Okay, and here you have okay, all the array values with this 0.7. If you want to go to another area, system automatically is changing these values. No? So in this case, it's 0.4 micron. So you see, depending where you take the profile, you will get much different values. Well, that's a bit what we wanted to show today. So again, thank you for attending. Thank you for your time, for your questions. I hope you like it. That's all from my side. Néstor, I think.
Thank you.
Okay. I hope, I wish you have a very nice day, and see you soon.